In this example, we have a bomb section of a distillation column, and we know that we need to control base level and base temperature or bomb composition with a different manipulated variable. So steam is being used to control base temperature, while our tails flow or our bottoms flow is being used to control our base level. In circumstances where even if this is fully shut, this tails flow is fully shut, and our base level gets too low, we're going to need some sort of function or some sort of controller to cut back on steam. So since steam, if we increase steam, we decrease base level, and we need a low level override controller, low set point override controller. We need a low select function block, as we can see here. So now let's go to our function we're using, because we're not using a PI controller in this example as our override controller. We're using a function, as we'll see in the next slide. So here's the function we're using. When base level is above 20, we can see the controller output that's being sent to this low select block is at 100. So not until our base level gets below 20, then this function can override our steam controller output. So if our base level is at 20 PV, override controller output's 100. If it's at 15, we can see it's 75. If it's at 10, it's at 50. If it's at 5, it's going to send a control output of 25 to that steam valve. And if the base level is at 0, we're going to fully want to shut the steam valve. So we have 4 blue dotted lines in this example. The first blue dotted line is a set point for the base level controller, which is controlled by the bottoms control valve, which let's say that set point is 50%. The second blue line is the set point for the override controller for base level. The third blue line is initial value for the bottom controller output, and the fourth blue line is the initial value for the steam controller output. And each red vertical line is a different sampling period. So sampling period 1, T1, T2, T3, T4, and so on. Suppose that the level controller goes below its set point 50. This would cause the bottom controller output to start decreasing, and you're going farther and farther as the level keeps on decreasing. The bottom controller output will eventually go to 0%. And so let's say at time period 7, our level goes below 20%. Now we know our override controller when base level is at 20% saying, hey, the steam controller should be 100%. And then once we get down to 16%, hey, it should be 80%, the steam valve. And so once it goes below the 16%, now it's saying, hey, the controller output needs to be below 80, below 80, below 80, below 80, below 80. So if we go to the steam control output, once we get to sampling period 10, where the level goes below 16%, it's like, okay, both the steam valve or the base temperature controller as well as the override controller are both telling the low selector block, hey, we both have 80%. So once base level gets below 16%, now the base temperature controller is saying, hey, keep the steam valve at 80%. However, we know the override controller at 15% is saying, hey, I need you to drop down to 75%. And then let's say 70%. as base level keeps decreasing. It's like, okay, now let's say this at T16, it's like 60%. It's going to keep going, keep going, keep going until, hey, base level is finally back to at least a stable position, 10%, and that last condition was 50% for steam. So that base temperature is telling the steam control output, hey, I want 80%, but since we're using a low select block, this override controller overtakes it once this base level gets below 60%, and then drives the steam controller output to a value until this base level starts to converge to some asymptotic value. So this is an example. I hope this helps you understand override controllers, how they can be used in distillation columns. Thank you for watching. Have a great rest of your day.